Today we're going to learn how to write the formula for an ionic compound. So ionic compounds exist as whole number ratios of ions to balance out charges. So you have to have 1, 2, 3, 4 cations, 1, 2, 3, 4 anions. And it depends on their charges. That's going to determine how many of each, so they'll balance out so that everything is electrically neutral. When you write your formula, never, ever, 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 ever put a superscript with the charge. It's just how many atoms are included. Charges aren't written in any formula, so make sure you're just putting the number of atoms in your formula at the end with those subscripts. So superscripts are up high, those are gone. Only your subscripts are in formulas. And first we're going to start with binary ionic compounds because they're the simplest. Binary, bi means 2, so it's made of 2 elements only. So 1 cation, which is typically a metal, and those are going to be listed first, and 1 anion, which is typically a non-metal. Remember, these are 2 atoms that have an electronegativity difference of 1.7 or greater. So I'm going to give you a bunch of these charts in the notes that are printed out, and they're just a handy dandy way to kind of organize your thought to determine the formula for things. So let's start with sodium oxide. So sodium is going to be the cation because that's written first, and oxide is oxygen, and that is your anion. Notice sodium, the cation, is named just as is. When you have an anion, that's an element, you just change the ending to IDE. So your cation is sodium, your anion is oxide or oxygen. So when sodium makes an ion, go ahead and look at your periodic table, and I want you to freeze this and figure out what charge sodium would make, and then also what charge would oxygen make. Okay, did you get 1 plus for sodium and 2 minus for oxygen? Now remember, if we were just writing this, we wouldn't put a 1 here, we would just put a plus sign, but for the chart I like to put a 1. So then right here in my chart I say LCM, which is least common multiple. So if I take 1 and I do the multiples, it's going to be 1, 2, 3, 4, 5. If I do 2, and I'm not looking at the negative sign, I'm just looking at the number 2, what are the multiples of 2? 2, 4, 6, 8. Well, which of those is the same on both lists, but's the smallest? And that number is 2. So this is what I'm going for, the least common multiple. So now number of each to make your ion. So I need a 2 charge from each one. How many sodiums do I need to have a 2 plus charge? And that's what I put here. I need 2 of them. Notice 1 times 2 gives me 2. For this, how many oxygens do I need to have a 2 charge? Well, each oxygen ion has a 2 minus, so one of them gives me my charge. I only need 1 oxygen. Well, these are your subscripts. So you're going to have Na2O1, and then we don't put the 1 in your formula. So Na2O, that's sodium oxide. Okay. Let's do calcium oxide. So the first one is your cation, so calcium, and then oxygen is your anion. So go ahead and look at calcium, find it on your periodic table, find oxygen, which we already did, so you should be able to fill in the charge already. And I want you to figure out what charge do these 2 things make, and check back in a second and see if you got it right. All right, calcium has 2 valence electrons. So is it easier to lose 2 or gain 6? Losing 2. So it's going to be a 2 plus. Oxygen has 6 valence electrons. Is it easier to lose 6 or gain 2? It gains 2, so 2 minus. And then what's the least common multiple of 2 and 2? Well, 2. They both start with the same number. So we need to get to an overall positive 2 and an overall negative 2 so that those 2 charges cancel out, and that way your total compound is neutral. So 2 times what gives me 2? 1. 2 times what gives you 2? 1. So these are your number of ions. So Ca1O1, you don't write the ones, so just CaO. Notice calcium has a 2 plus and oxygen has a 2 minus, and those 2 things cancel each other out, so you have an overall neutral compound. All right, If you ever see an ionic compound that has more than 2 elements present, then you're going to have a polyatomic ion somewhere in here. So this is a big old list of polyatomic ions. There are more than this list, and for the academic chemistry course, you're always going to be given this. So in your notes, there's going to be this whole chart. You don't have to memorize it, but you do want to be familiar with it. So if there's more than 2 elements present, and it's an ionic compound, one of the ions is going to be a polyatomic ion. And poly means many, so groups or many, atoms, atomic, held together by covalent bonds, but it overall has a charge, which means it's an ion. When there's multiple or more than one of the same polyatomic ion, you're going to put the polyatomic ion formula in parentheses and write the subscript outside of the parentheses, so that way it tells you how many of that polyatomic ion. So for example, say you had multiple dihydrogen phosphates. This whole thing would go in parentheses, and then outside you'd have a number, and that says how many of the whole thing are going to be in it. So let's do an example. Let's say you have gallium chromate. Now something to look for at this. See how this has an 8 at the end? That tells you that it's a polyatomic ion. It didn't end with "-ide". If it was an element that made the anion, it would end with "-ide". So gallium is your cation and chromate is your anion. And then your charge is already given to you for your anion because chromate never has another charge. But gallium, you need to know, is 3+. Chromate is 2-. So what's the least common multiple of 3 and 2? Well, let's go over our 3's first. We've got 3, 6, 9, 12. Let's go over our 2's, and the first one we hear that was on the list of the 3's is going to be the least common multiple. So 2, 4, 6. 6 was on both lists, and it's the smallest one. So 6 is your least common multiple. 3 times what gives you 6? Well, 3 times 2. 2 times what gives you 6? 3. You might notice that often these numbers switch places here. It doesn't happen for every single one, and we'll go over, like if you go to the last one, calcium oxide, you don't get to just switch it because then it would be Ca2O2, but if they have different charges, then you do actually switch the numbers, and then you could see if you have to reduce at the end. So I've got 2 galliums to make a positive 6, and 3 chromates to make a negative 6 so that those 2 will cancel. So gallium has 2, so Ga2. But I need to say I have 3 of this whole thing chromates. So here it is, Ga2, and since I have 3 of all of the chromate, that's put in parentheses. Let's try another one. Let's talk about transition metals. They do not always have the same oxidation number or charge. And the oxidation number is written with a Roman numeral in the name to tell you what the charge is for a transition metal. Remember that metals always make cations. So when you see that Roman numeral, you know it's telling you what positive charge that element gives you. So for example, iron 3 is Fe3+, iron 2 is Fe2+. Notice they're both positive, and the number here correlates with the Roman numeral. All right, so how about this one? Copper 1 nitride. Notice IDE, so I know this isn't a polyatomic ion because it ends in "-ide". So copper 1, that's my cation. Nitride is my anion. Well, what charge is on copper 1? It's right there for you, +1. Nitride is nitrogen, so you have to look at it on the periodic table. Remember, I know that it's elemental because it ends in IDE. Nitrogen has 5 valence electrons, so is it easier to lose 5 or gain 3? Gain 3, so 3-. What's the least common multiple for 1 and 3? That's going to give you 3. 3 and 1 will be the number of ions, because 1 times 3 is 3, and 3 times 1 is 3. Again, notice these numbers are different, so they switch positions here. That doesn't mean they switch charges or anything like that. It just tells you an easy way to figure out how many numbers of each. So I'm going to have 3 of my coppers, so Cu3. I have 1 of my nitrogen because that's here, so I just say N. Don't put the 1 as a subscript. And like I mentioned before, remember at the top there's nothing written here. Like we don't have any charges or anything. Your numbers and your formulas just go on the bottom. All right, so now it's your turn. Here are quite a few things, quite a few ionic compounds, and you're given the names of each. You can use the chart as a guide, or if you want to figure out your own way, but go ahead and freeze your screen and come up with the formulas for each, and then when you're done, check and see if you're right. Okay, freeze your screen. All right, so here are the correct formulas. Did you get them? If not, go ahead and ask your teacher for help. Okay, thanks.